Okay, welcome to part 3. This is the last part here. So now we can have a little bit of fun with these properties. So we know that uh, the if we're adding two logs with the same base, that we can combine them with multiplication. So now we have log base 10 of 50 times 2, which is log base 10 of 100. But we know something about 110. 100 is a power of 10. So it's really saying log base 10 of 10 to the second power. And we also know that if you have the same bases here, that they kind of, I guess you could say, kind of cancel each other out, and you're left with just the exponent. So the final answer to this is just 2. Right? And you can verify this in the calculator as well, but this is like something we could do without calculators. So looking at this next one, we have log base 3 of 54 divided by 2, which is log base 3 of 27. And we also know that 27 is a power of 3. So we get log base 3 of 3 to the third, which is just 3. Okay, so now this uses another property of logs. Now we're kind of going in reverse here. We're raising it to the same log base. So let's condense this a little bit. So it's 5 to the log base 5 of 3 divided by 9. So it's 5 raised to the log base 5 of 1/3. And again, a property that we know from all the way up here. This is exactly the same picture that we have. It's just equal to that input. So this is equal to 1/3. Okay, so same thing here. 4 to the, we're adding here, so it's log base 4 of 2 times 32. So it's 4 to the log base 4 of 64. And again, these are the same base. So they kind of cancel out here, and we're left with just 64. Okay, now to make life easier when we have radicals, as we do in these next 3 problems, it's great if we can rewrite this as an exponent. So instead of saying the cube root of 125, we could say it's log base 5 of 125 to the 1/3 power. Now there's a lot of ways you can go around doing this problem. You could actually evaluate 125 to the 1/3 power. You could evaluate it up here, or you could change 125, because 125 is a power of 5, to log base 5 of 5 to the third raised to the 1/3, which is just log base 5 of 5 to the first power, which is just 1. Over here, this is to the 1/5 power. Okay, so log base 2 of 16 to the 1/5 power. And now I could change 16 because I know 16 is a power of 2. I could rewrite this as log base 2 of 2 to the 4th power raised to the 1/5 power, which is log base 2 of 2 to the 4/5 power. And since they are the same base, we're left with just 4/5. Okay, so again, challenge yourself and try some of these. Try some of these on your own. Okay, so just hit the pause button. Now look at this one. Okay, this is the natural log of e to the 7/5 power. And the natural log of e, these will cancel because they're opposites of each other, and we're left with just 7/5. All right, I love these problems here. These are nice challenge problems. So we're going to be using the change of base formula, but in a kind of a different way. All right, so we're multiplying 2 different logs, and what they're asking us to do is to rewrite this using the change of base formula. So now we're going to have common log base 7 over log base 3 times log of 9 over log of 7. So again, this is something you got to see. Once you see it, you'll see it forever. It's like riding a bike. Like you'll never forget how to do this. So now we have log 7 over log 7. Hopefully you guys see that we can cancel this out, and we're left with log base 9 over log base 3. And now we're dividing two logs here, but I also know that 9 is a power of 3. So now this is log base 3 squared over log base 3. And I also know that if I have an exponent here, I'm allowed to put it in the front. So now this is 2 times log 3 over log 3, which is just 2. I know, it's crazy to think that this is just equal to 2, but it is, and we just take the time, we put it in and put it into little pieces. All right, I'm going to try something new here. I'm going to move this around. So let's see if I can do this. I'm going to move this over so I have room. Oh, look at that. All right, perfect. All right. So now let's try it for this one. Again, pause if you want to try it on your own. So I'm going to use the change of base formula here. So I'm going to write below this up, write small because we have one more. So log 13 over log 2. And again, I picked common log. If you want, you can do natural log. I was feeling common log, so I did that way. Times log 32 over log 13. And notice these are the same, so I cancel out. I'm dividing them, and now I just get log 32 over log 2. And again, hopefully you notice that 32 is a power of 2, so I can rewrite this as log of 2 to the 5th power over log of 2. And one really nice property, I said we use this one a lot, is I could rewrite this as the coefficient here. So this becomes 5 log 2 over log 2, and the answer is just 5. And again, I know it looks like it's like a foreign language here, and you're like, how do you look at this and get 5? Well, you just do it piece by piece, okay? Accept the challenge and try it and have fun with it. All right, let's try it again. Again, hit the pause button. This is a really challenging one because of the exponent, but try it. So, log 5 over log 4, I'm using the change of base formula, times log 64 to the x over log 5. And these are the same, so I can cancel them out, and I'm left with log 64 to the x over log 4. And I know, and again, hopefully I know, that 64 is a power of 4. So I can rewrite this as log of 4 to the 3x power over log of 4. And from here, use that nice property we have of logarithms. This becomes 3x times log 4 over log 4, which is just 3x. How many of you guys got that? Hopefully everyone. All right, moving on. Express as a sum or difference of logarithms. Okay, this is expanding. Kind of did this a little bit of this already. So expanding these. So you're going to see a really nice relationship here, and this is again you're going to have to do this on the final. Okay, so this is why we're teaching this. I'm only teaching the things that you need to do. You need to do all of these. Okay, and you'll see I did cut some stuff here at the end. Right, we're not going to do this. Okay, that's cut. Right, but you do have to know how to do this. So, log base 5 of 25 times x. Again, recognize that this is a product. So I can rewrite this as log base 5 of 25 plus log base 5 of x. And in doing so, I know that there's a relationship here with 25 and 5. This becomes log base 5 of 5 squared plus log base 5 of x. And this just becomes 2 plus log base 5 of x. Again, you're looking at this answer, you're thinking, well, that's not any more confusing than it was originally. Yeah, I know, but they asked us to expand, and this was what expanding means. You're trying to get it as spread out as much as possible. Okay, So same thing here, put our visible parentheses. So this is natural log of x minus 8 minus natural log of e to the 2x. And this one is kind of like a softball here. It's pretty common. You see natural log and e, they cancel out. So finally we get natural log of x minus 8 minus 2x. Now some of you guys might be thinking, well, couldn't you expand it by distributing natural log to each of these? No, we're not going to do that. You don't do it that way. It doesn't work like that. All right, so we leave it like natural log of x minus 8. Okay, and over here, this all this is saying is this is your domain. We had to say that x is greater than 0 because of this. You can't take the log of 0. So that's all. Don't let this confuse you. Everything is still the same. So log of x times x plus 3 minus log of x plus 5 to the 8th. And then this is a product, so I can split this up even more. Log of x plus log of x plus 3 minus, and we're going to put this in front to make it even look like larger. We're expanding it, minus 8 log of x plus 5. So this is what it means to expand. And now we're going to condense. Okay, and there's a question like this on the final, okay, and we'll prepare you for it. And you're just trying to write it as a single logarithm. And in the review, we'll give you some of the tougher ones that you'll see on the final. There's only one question, so don't get too nervous, but you can handle it, right, and accept the challenge. So now we're trying to write this as a single logarithm, like if at all possible. That's what we're trying to do. That's what condensing means. So a single logarithm means just one log. So a couple things we could do right off the bat. You see these numbers in front. I could put them as exponents. So now we have log base 3 of u to the 6th plus log base 3 of v to the 5th. And then hopefully we recognize if there's a plus sign, we have the exact same base, we can rewrite it as a product of a single logarithm. So we can rewrite this as log base 3 of u to the 6th times v to the 5th. And that's what it means to be a single logarithm. Okay, over here, the same idea. It's a little bit easier, I guess, because it's just the same base and there's a minus sign in between, and you already have it as an exponent. So this just becomes log base 7 of root x over x to the 11th. I would leave it like that. You could, like if you wanted to, you could rewrite this as x to the 1/2 over x to the 11th, and then you could use exponent rules and subtract 1/2 minus 11 and get log base 7 of x to the negative 21 over 2 power. But there's no need. This is a perfectly good answer. Okay, lastly, again, this one you definitely want to pause and try it on your own. So pause. Okay, so recognize right away, I could put these coefficients and rewrite them as exponents. So now I have log base a of 7 times x to the 6th power raised to the 3rd minus log base a of 5x plus 19 raised to the 1/8 power. And now we recognize subtraction, recognize the same base, so I can rewrite it as a single logarithm. It's going to be a little complicated, but I mean, again, you're following the steps, so just have confidence in your abilities and know that you're doing it right. Okay, and again, it's a single logarithm. The biggest mistake, if I remember from last year, is kids wanted to write log a over log a. No, you don't have to do that. This is it, right? You're writing it as a single logarithm. All right, last few things here. I love these questions. We're going to end with these. So make sure you have this. We're going to end with these, and these are like, I've seen these on the ACT and SAT before. So they're giving you a definition. They're saying log base 7 of 2 is A and log base 7 of 3 is B. And what you have to do is find those hidden here, right? And these can be kind of fun, right? Because you can like say like, oh, how could I write this? You can like put hidden messages. So log base 7 of 6, well, we know that 6 is the same thing as 2 times 3. And so then if we can rewrite this, and we can write this as log base 7 of 2 plus log base 7 of 3. And look, log base 7 of 2 is A, log base 7 of 3 is B. So this is just A plus B. Okay? All right, over here, 8 is the same thing as saying 2 to the third power. So again, log base 7 of 2, I already have a definition. That's just A, so this becomes A to the well, actually, you kind of want to move this thing in front, right? So now I'm going to write this x1 in front. So this is 3 times log base 7 of 2, and this then becomes A. So this is 3A. Okay, over here, you might say, well, I don't see it. That's okay if you don't see it, but remember, we need things to be in terms of 3 and 2. So now log base 7 of 4 minus log base 7 of 27, and 4 is 2 squared, and 27 is 3 cubed, and this becomes 2 times log 7 of 2 minus 3 times log 7 of 3, and here we go. Here's your log 7, 2, log 7, 3, and we get 2a minus 3b. So everything's going to be expressed in terms of a and b. All right, last thing for this lesson. Tune in for the next video. Next video will be our last official notes video, and then we'll start the review. So we want things in terms of 4 and 5, right? So this one is kind of a little tricky here because you're like, well, 12 is on a power of 4. You're right, but we also have log 3, so check this out. If I write this as log 3 of 3 times 4, and I rewrite this as log 3 of 3 plus log 3 of 4, now log 3 of 3, that's just 1, and log 3 of 4 is a. So 1 plus a. Okay, so again, 100 is not a power of 5, but it is, you can rewrite this as 4 times 25. And now here is your log base 3 of 4, but your 25 is, remember, it's 5 squared. So now we have log base 3 of 4 plus log base 3 of 5 squared. That 2 comes out in front. Log base 3 of 4 plus 2 log base 3 of 5. And we get a plus 2b. See what I mean? Like, it's like a puzzle. Have fun with it. Challenge yourselves, right? You want to make sure during this time that you're working out your brain as well as your body, as well as everything else to keep you sane during the home stay in place rule here. All right, so like this is working your brain for sure. All right, this one's kind of an easy one, right? 30 divided by 6 is 5, so we have log base 3 of 5 already without doing any work. All right. Actually, the reason why this is up here, there's a lot of students who want to try to like make this harder than it seems, and sometimes the answer is right in front of you. Okay, that's it for today. Watch these videos, pause them, put them at your own speed, and we'll see you next time.